Okay, so we're going to practice graphing reciprocal functions, starting with a linear function. So I have the equation of the line y equals x minus 3, and I've graphed that already here on the axes above. It's always important to start with your original function, so that's what we've done first. And I'm going to break this function down by looking at some of its key properties. So the first thing I'm going to look at with this function is the x-intercept. So for this line, we have an intercept at -3. So I'm just going to write that as a coordinate first on the page. And now what we're going to do is look at how this graph right here is divided into positive and negative intervals. So what I mean by that is if we take a look at all the y values above the x-axis, we see that they're all positive. Any of the y values below the x-axis are negative. So if we notice where the line crosses the x-axis, we can divide this up into the section of the graph that contains only positive y values and the section that contains only negative values, y values. So the graph that occurs before -3, anything before -3, is only in quadrant 2, and like I said, anything above the x-axis is positive. So we have a positive interval for all the x values from -infinity up to that -3. We're always going to get a positive y value out. So we write that interval here. Now that means that anything after -3 has crossed into negative y values. So I will label that next. We have our negative interval, or negative y values, all occurring after -3. Okay, and that's all below the x-axis. Next for this line, I'm going to look at where the line is increasing and decreasing. So remember, we're always reading the graph from left to right. So I look at this line from left to right, I see that the y values are continuously decreasing. They're always getting smaller the entire time. So in terms of our increase, I'm just going to say that there is none. There's no interval of increase. Instead, what we have is an interval of decrease that goes all the way from -infinity right across the page to positive infinity. So the graph is always decreasing. I think that's it in terms of what we want to look at right now. What we're going to do is compare this to what the reciprocal of this specific function is going to look at. So some qualities you're going to notice are maintained, and some of them are going to change when we move into the reciprocal function. So one thing that occurs in the same spot is this 0 here. Now, the difference is that instead of being a 0, if we took a y value like 0 and we flipped it, what's actually happening is the coordinates of this point would have to be written as 1/0. Now that's something that we can't graph. So what does this mean? This means that at the point when x equals -3, this instead turns into a vertical asymptote. And the equation of the vertical asymptote is x equals -3 because our y value becomes undefined. We've flipped it, we've made it a reciprocal, and now it doesn't exist anymore. So that means on the graph, I'm going to draw a vertical dashed line right through -3, and I'm going to label that so I know what that is. And that represents our vertical asymptote. So that's our first characteristic that we can match. Now, in terms of positive and negative intervals, how does that show up on the reciprocal? Well, I try to remember that when I take the reciprocal of a number, it never changes the sign. For example, if I had a number like 5 and I took its reciprocal, it would be 1/5. If I took a number like 10, it would be 1/10. I'm never changing the sign. If I had a number like -3, the reciprocal of -3 is -1/3. So just because I'm turning this graph into its reciprocal, the positive and negative intervals that I have are going to be the same on the reciprocal graph. So what that means is the reciprocal graph is going to show up with positive y values everywhere that my line showed up with positive y values, and the reciprocal is going to have negative y values everywhere that my line had negative y values too. That means my graph is never going to appear here in this section, and it's never going to appear up here in this section. It's going to stay in these two areas of the graph. Now, what does change is the shape of the graph, what the graph looks like in that sense. So the reason that occurs, and what I try to think of, is if you listed numbers in order, so in a decreasing order. So let's say I even just took 5, 4, 3, and 2, and I wanted to turn these into reciprocal values. They would become 1 over 5, 1 over 4, 1 over 3, and 1 over 2. But notice the first pattern is a decreasing pattern. The second pattern, these fractions are actually getting bigger. So they're opposite to each other. For that reason, when we look at the intervals that were increasing on this line, they will turn into decreasing intervals on the reciprocal. And anything that was decreasing on this line will turn into increasing intervals. So instead of having a line, in the place of this line that is decreasing, my reciprocal function, those values are actually going to get bigger instead of smaller. So the graph turns into an increasing graph. Now, I can't just write from negative infinity to positive infinity because this graph is going to break where the asymptote is. It's not continuous like this line is. So what I'm going to do is I'm going to sketch the graph first. I'm going to sketch it first up here in my positive section, but instead of a decreasing line, it's going to change to an increasing line. Something I'm going to keep in mind as well is that this value where y equals 1 should correspond to a point on the reciprocal as well. So I just followed 1 across like this. Now I'm going to draw a graph that approaches the asymptotes and increases. So this function, this function here is now an increasing graph. Now down here, again, they're negative y values, but they have to increase as well because this line is decreasing. So I'm just going to take -1, match it along over here, but I'm going to draw a graph that is also increasing from left to right. Okay, so line is always decreasing, my reciprocal is always increasing, but break at the asymptote. So the way I'm going to write my interval of increase here is that it's going to increase from negative infinity to -3 and from -3 to positive infinity. That way, especially with a rounded bracket, I'm showing that there isn't actually a value happening at -3, but everywhere the graph exists, it is definitely increasing. And instead for decrease, now I write none. And that's a fairly accurate sketch for the reciprocal of y equals -x minus 3.